Hi, this is the 3D Physcs and our project is on collision. We're going to explain both elastic and inelastic collision. And first I'd like to do a generalization of what collision is. So first of all, in terms of physics, it is the meeting of particles or bodies, and upon meeting there's an exchange of energy and momentum. When objects collide, sometimes the objects involved deform and the energy that causes this deformation is taken from the kinetic energy of at least one of the objects. Also, as this is taking place, friction takes some of the kinetic energy and turns it into heat. The important thing to remember is that during a collision, momentum is conserved and energy is not created, it is transferred. There are two types of collisions that we'll be going over, like I said, elastic and inelastic, both of which conserve momentum. First off, we'll be talking about elastic collision, and then we'll be doing a demonstration with two pool balls. So elastic collision is when kinetic energy involved within the collision is completely conserved. In other words, the kinetic energy going into the collision is the same after the collision. During elastic collision, the energy converted to heat and deformation are so minimal that usually you can say that the kinetic energy was completely conserved. In our video, we demonstrate elastic collision with two pool balls, and as you will see, the two balls will collide and immediately go their separate ways. Generally, the losses to heat and deformation are so minimal that they can be ignored. So let's go over here, and we will do the demonstration with the two pool balls. Uh, so we have one with Chase, and then Yamina has the other one. Hold on. Let me just tilt you guys down. All right, go ahead.
We'll try again.
Go ahead, Joe. Nice. Okay. So as you saw, the friction was very minimal, that the balls, upon colliding, immediately went their separate ways. That is to say that the energy was completely conserved. So the energy that was put into it, creating the momentum, is the same when they hit and go their separate ways. So that was elastic collision, and later we'll demonstrate inelastic collision. But first I'd like to tell you guys what that is exactly and how that is different from elastic collision. So inelastic collision is when kinetic energy is transformed by friction and deformation. Within an elastic closed collision, the kinetic energy completely changes. If you can observe a change within the energy because of the collision, then the kinetic energy isn't conserved. In our video, we dropped what is called FLARP, which is a gooey substance that is like silly putty on the pool ball, and observe what the FLARP does. Basically, it'll deform around the pool ball. Pretty much saying that the kinetic energy is then transferred into the deformation and maybe some friction. Either way, the kinetic energy will not be conserved. So let's go over to the demonstration. I'll take you guys down again. And as you can see, upon the collision, it just deformed completely. So instead of them going their separate ways, they just collide with one another and deformed and connected. So that's pretty much the difference between elastic and inelastic. As we discussed, elastic is one the energy is conserved, and inelastic is one it is not conserved. In both, however, momentum is conserved, and that concludes